Is that correct?
Yep, it's working just fine.
Okay, then Marie, I think you have the host rights back, so I hope everything is fine.
Let's hope everything is fine. Okay, so it's 12:03, so I'll be starting, okay? Hi, everyone. Welcome to the ASEE&T online tutorial. My name is Marie Lefebvre, and I will be the technical coordinator of this meeting. As you may have noticed, most participants are presently forced mute. If you have a question related to the presentation, please use the chat tool at the bottom of your screen. You can see it now with a little number 1 in red. So this is where you will be writing your questions, and in 45 minutes from now, we will answer the questions. If you have a technical problem, again, use this chat tool and write your concern, and Bastian Tenberger or Jean-Philippe Bernius will answer you and try to help you. All the documents required for the exercises are available through a link provided in the chat. This is why you see a little number 1. So all you need to do is click on this link and you will get the documents. So thank you very much.
We do not have the link yet. There's nothing. I don't see it in the chat, Marie.
Well, you should see it because I've posted the message in there. Yeah.
Okay.
Anyway, I will repost it again if necessary.
Go ahead.
Okay. Yes. So thank you very much for your attention. And now we will proceed with the presentation.
Okay, thank you very much. I'm John Impagliazzo. I helped organize this tutorial with 2 wonderful participants, Nancy and Pierre. And what we want to do is to take this time, it's a 3-hour block, and basically partition it into 4 group major sections. One is the presentation of the different components that we will be speaking about, and that'll take about 45 minutes. Then the second thing will be familiarity, which is called Activity 1. The Activity 1 is to become familiar with the different documents that are available. And then there'll be a break, and then Activity 2, where it will be a creative thing to create, in effect, competencies for software engineering. And then to have a open discussion on where do we go from here. So could you advance? Okay. Mehdi, could you advance?
Are you there?
Yes, I'm there. Yes.
You would advance the slides and put it in presentation mode.
Ah, but I did. I don't understand why you don't see it, because I see it on my screen.
Okay.
Maybe your screen, do you have 2 monitors? Maybe
yes, I do. Yes.
Maybe you're screen sharing the wrong monitor then.
Maybe.
You can try to press X.
We'll wait until this
it switches the screen in PowerPoint.
There we go. You see it now?
Yes.
Yes.
Okay,
just go back. Good. Yeah, go back to 2 or 3 slides. Yeah.
Okay, very good.
Yes.
Okay, very good. Okay, if you can go to the timetable, which is the 3rd slide. Okay, very good. This is the breakout in terms of the 3 hours, the 180 minutes, and that should take us to the end of the session. This presentation is available on the links, so if you want to go back to any piece, or if you missed what I had said or someone else had said, you can easily go back and look at it while we go ahead, because we are in time limits. Okay, so let me explain to you the next slide. This project called CC 2020. It's Computing Curricula 2020. It's a big project, and its focus is on competency. And it's more of a formalization of competency as opposed to just using it as a word. So let me give you a little background of this. Next slide. Okay, the principal sponsors for this is ASEE&T and the IEEE Computer Society. We've had endorsements from all over the world. They keep coming in. The last one was from Brazil. It has been a large undertaking of about $200,000, and it involves 50 professionals, mostly academics, but maybe 15 industry government types, 20 countries and 6 continents. We apologize, we could not get anyone from Antarctica. And so what is this project? It started 3-4 years ago, and it's a modern replacement for the CC 2005 project, which was Computing Curricula 2005. If you're not familiar with 2005, let me give you just a little bit of background for it, but we could advance. Next slide. Okay. This 2020 project has these elements as chapters, okay? So it's very instructive and very historical. It talks about how computing education evolved, went from knowledge, competency, and then to visualizations of these things. And then very interestingly, the global and other perspectives as this project hopefully takes root. Next slide. Okay. For CC 2005, it's probably best known for these images. These images basically back then, I was on that committee, and we've had big battles about what the shape should be, but this here defines what computing was. Okay, and it also provided ways by which you can look at different disciplines in terms of their content, in terms of their expectations of graduates. So you could find this document. You just go to the acm.org and go to the education link, and then go curricular recommendations, and you will find this among the early documents. Eventually, the CC 2020 document will be there, okay, and it will be available, and it's available for free for everyone in the world. Next slide. So what was the issue that we confronted? All the curricular recommendations were knowledge-based learning. Basically, there was a body of knowledge. There was some facts that people would know. Students basically had to pass an exam. There was no big emphasis on skills, although skills did occur in certain laboratories. But for the most part, it was just, learn some facts about whatever discipline, and then see if you could reproduce responses to questions on exams. This is not the way the world works in the engineering and in the computing fields. So we started addressing this in a more concrete fashion. Next slide. Okay. All right. So in the past and in the current, we want to look at this. We had this body of knowledge. Okay. We had some kind of domain that it encompassed. It was like a collection of terms. Exams could be like, multiple choice type things, or fill-ins, problem solving, of course. The result of that was that there was an expected learning outcome for these things. So the learning outcomes, these are the statements, was what the learner is expected to know and demonstrate. And they generally demonstrated that by passing an exam. So the the situation got a little bit complicated because this is what people tend to know. And they tend to do. And I was taught that way, and my teachers were taught that way, and I probably taught my students mostly that way, but the world has changed. And the next slide. So we have this calculo syndrome that we like to call in a sort of a funny way, but we have knowledge areas, we have knowledge units, and we have learning outcomes, okay? So what's wrong with that? You know, it's worked for decades, perhaps millennia. So in today's world, there is other expectations. And so we can't just focus on knowledge alone. The achievement for this type of learning was, as I mentioned earlier, test results. Student may lack maturity and performance. If they go on a job, they really can't perform at the level they expect to know. And it's probably not beneficial for today's computing and I would say / engineering world, where there's a greater expectation. So in effect, what the universities have been producing were good, smart, graduates from their programs, but industry finds it's difficult to hire them. And so we kept asking why. So we have a few pickups. Next slide. Okay. So the thing is, from a referenced document, there's about 80% of Americans, US, agree that there's a skills gap, okay? 42% were underemployed. And you can go through these types of data. 60% of employees have job openings that stay vacant for 12 weeks or longer. And 75%, I think, graduates lack adequate innovation and diversity skills. So this is from industry. And industry understands that the universities produce the graduates, but they really can't hire them the way they would like. Next slide. Okay. So if you go to the Bureau of Labor Statistics, they produce, expectations. The second column is 2018 jobs, 2028 jobs. Okay, and we see there's this job increase from the Bureau of Labor Statistics. And this gives you at least a trend on where the jobs are going. And the question is, can we fill them? And in computing, I don't think we graduate more than 30,000 students each year. So it's going to be very, very difficult to achieve the future expectations of this from the current, baseline. So next slide. So when you think about, ask the question, which percent of current graduates from undergraduate computing or engineering programs continue full-time in their formal education? That means they go full-time as a graduate student. And if you're from a, tier 1 type university, research university, the number would be high. But for the other universities, especially worldwide, it is rather low. Most students after graduation go into industry. So, and we did some studies on this, and we did some research, and it's about 3 to 5% of the graduates go to graduate school, which means about 95% or more will go into industry or government. And so the question then comes up, are we producing the graduate that would be satisfied by industry? Next slide. I'm sorry I'm going quickly with this, but we lost some time and I wanted to make up. All right, so one of the big things that come up is competency. And from the ASEE&T document on computer engineering, competency is, of course, refers to the performance, okay, of certain standards and or accomplishments, okay. From the software engineering side, from the software engineering competency model, competency is the demonstration or the ability to perform work activities. So we have this sort of independently done, where performance is the key word for competency. Next slide. So in the information technology report, which is IT 2017, we've taken the model that's used in medical schools, and which is a mixture of knowledge and skills and dispositions taken in context. For the industry perspective on this, we were told, especially doing the IT 2017 report, which I was a member of that, and by industry research through CompTIA and Burning Glass, that the greater interest is in the dispositions. That means the students, the human ability or attitudes, their skills, and then knowledge. In fact, some people would say they don't care if they have an MBA, as long as they can have the right attitude and the right skill set for the job, that's sufficient. And we're seeing some of that now in the major companies. Apple and many other companies are now just ignoring college graduates, and they're just taking students who are bright and have the right disposition from high school, and then they just train them for what they need to do. I realize as an academician, this is not what we expect, but this is what's happening. So, and we don't deny it's happening because that's actually going on. Next slide. All right, so a picture of this is that if we want competency, it has to be in the intersection of the people with knowledge, with skills, and with the dispositions. And the reason why disposition is the greater set is because of the industry perspective. They need people with the right attitude and the right mindset, okay, to be a, like a team player and be punctual, et cetera, all those human attributes, then the skills and then the knowledge together. So in the CC 2020 draft report, knowledge and skills tend to be like a couple's pair. So there was a big discussion about this, whether they are independent, but we take it that if you have a skill, you also have to have some knowledge about that. So if you're a pianist and you're a musician and you are skillful playing the piano, you need to know something about the music and the theory of music, etc. So next thing. So what the group CC 2020 report did was to, in effect, semiotic partition, which is mostly overlapped anyway, it's not the pure partition, that there are 6 general areas. There's the hardware, the nuts and bolts area, the software, both in fundamentals and development and systems. And then there's the modeling, and then there's the human and organizational issues, which information systems, which is another computing area, deals with. So, so this is how they sort of partition this here. Now, this is not satisfactory for software engineering. We'd have to have our own computing knowledge set of or categories for this, but this is how all of computing. This is all of computing, not just a specific area of it. Next slide. So what they did, they took knowledge, which is this computing knowledge, and they coupled it with what they call professional knowledge, and there are 13 elements of those. I won't repeat them, but they're in the presentation that you could download. But something like being having analytical and critical thinking is important. It's a sort of a knowledge skill. Being familiar with mathematics and statistics and having oral communication skills and presentation and having time management. These are things that you learn and you try to obtain on a sort of a less formal, but you learn them either by experience or by other methods. Next slide. So these knowledge elements, remember there was the pair, the coupled pair between knowledge and skill. Okay, so these were the skill levels. They start with remembering and understanding, and they go down to evaluating and creating. This is very reminiscent of Bloom's taxonomy. So what the CC 2020 report did was to couple this understanding of these 6 levels to knowledge, whether they be computing knowledge or engineering knowledge or professional knowledge. Next slide. Okay, and then what about these attitudes and human behaviors? These are more or less instinctive, and this is what industry really looks for. If you go to an industrial advisory board and you present them with, suppose you had students having half of these, they would hire them right away. In other words, are they self-directed? Are they responsible? Are they meticulous? Are they inventive? These are kinds of things. Now, I'm not saying this is an absolute list. This is the list that's in the CC 2020 report. But like anything else, you may think that this is not sufficient or it's too much. And therefore you could modify it. The CC 2020 report is basically a framework for doing future things. Okay. Let's see, I think I'm almost out of time, so go to the next slide. Okay. So what we've done in the CC 2020 report, we created competency statements, okay? And you can do this way, or you can do it in reverse, but you could dissect the competency statement into the knowledge elements and the skill levels. So here's the knowledge skill pair, and then which dispositions relate to that. So I'm not saying you have to study this one and this is absolute, because these statements often depend on not only the profession, but also local situations, you know, like the mission of the department or the mission of the university. So much of our work today will be looking at these competency clusters. And go to the next slide. I'm sure you understand this very clearly, okay? But this is a publication that I wrote for the Chinese Computer Federation. You see my name there in both English and Chinese on the right, all right? But if you go to the next slide, all right, the title of this is The Role of Competencies and the Future of Computing Education. I was told that the Minister of Education read this article that I produced. I don't know how true that is, but I think it's something that you see that this is a global thing, where there is a global attitude to try to move away from just knowledge and move more toward a competency-based way of learning. Okay, so that concludes my portion of the presentation, and I turn it over to Pierre. Sorry, I'm 1 or 2 minutes over time, but go ahead.
Thank you, John. Thank you. Good day, everyone, or good evening, or good morning, or I don't know exactly what it is. Good day in the general sense of the term. So John so far has been talking about competencies in the context of curriculum and curriculum objectives and curriculum design. I'm going to give you a little bit of a broad, very quick perspective of competency frameworks that are available in the software engineering field or in the IT field or computing field more in general from in industry. There are various models that are available, and they extend beyond curriculum design, but also for career development and so forth. So I'm going to give you a few examples of that. And you'll see also that competency frameworks and competency design is very popular and is widely used and has been around for quite a while. And then I'm Canadian, so in the Canadian context, and in fact, in the context of my specific school in Montreal, I will give you an example of how perhaps we could use competency statements for a curriculum in the context of Canadian engineering accreditation. Next slide, please. So my first of all, I'm going to talk about SWECOM, and which stands for Software Engineering Competency Model. Just hold on a second here, I'll do this correctly. And the set of competencies that we will be starting from for our exercise was largely based on this model, not necessarily entirely, but the starting set of the competencies that are in the CC 2020 for software engineering that we will be working on. The starting set for this set of competencies comes from the SWECOM. The SWECOM was published in 2014. It was put forward by a number of people who worked on this initiative and had various validation processes. It is based on a certain number of consensus-based standards, such as the SWIBA guide, the IEEE standard 12207, the software assurance competency model, the graduate software engineering curriculum guidelines, and the undergraduate software engineering curriculum guidelines. So it is based upon, I would say, consensus-based reference document. It does not prescribe any any tool, process, approach. In fact, the various competency models that or frameworks that I will be presenting are all agnostic, if you wish, in this approach. And it covers technical skills, but does not include project management or general management. Those are covered in other documents, such as the project management body of knowledge put forward by the PMI and the extension to the PMI for the software engineering. Of course, one of the intended audiences, but not the only one, of SWECOM, as specified in the SWECOM document, is curriculum design, but others, since it could be used for career development, HR, staffing issues, developing role profiles, and so forth. So it can be used for other things than curriculum design. In fact, the various models that I will be presenting, it is the case as well. Next slide, please. Can you get to the next slide? The four of us developed a whole set of new skill sets, in fact, on how to manage all these tools in a virtual session. So we have the 5 components of SWECOM on this slide. So the requisite knowledge, which is essentially the body of knowledge underlying the competency models, things that such as you would find in the guide to the software engineering body of knowledge, but elsewhere as well. A list of related disciplines, they are only listed in the guide. They are very similar to, in the SWECOM, they are very similar to what we have in the SWIBA guide: computer engineering, computer science, general management, and so forth. We have cognitive skills, things like reasoning, analytical, problem solving, and innovation. The cognitive skills are not used in the same sense as in CC 2020, and they would be more similar to, and what John has presented to us in a previous slide called in CC 2020 professional knowledge elements. And we have also behavioral attributes and skills, things like enthusiasm, work ethic, trustworthiness. These would be similar to the dispositional elements that John presented to us earlier. And the vast, I would say the vast portion, by far the largest portion and the main focus of the SWECOM is on the technical skills. And I will be showing this a little bit in the upcoming 1 or 2 slides. And these technical skills, I would say to a large extent, were used to develop the set of draft skills for curriculum design that are in the CC 2020 document and an appendix, and from which we will be working in the when we start working for real, and not just listening to us, in the latter part of this tutorial. Next slide, please. So there are 2 sets of technical skill areas in the SWECOM. The first one is called life cycle skills, which essentially map to certain phases, if you wish, of the life cycle, software life cycle, or software engineering life cycle, without I would say putting forth a specific life cycle model. It could be agile, whatever it happens to be, but there are I would say very high level generic phases. And then the second one are cross-cutting, and you'll see they can apply. They could be cross-cutting to one of the life cycle areas, or they could be cross-cutting to another cross-cutting life cycle area. They could be seen also as specialty areas. Next slide, please. So here you have the list of life cycle areas. Nothing very similar on the left-hand side to what you have in the SWEBOC guide. So software requirement skills, software design skills, software construction, software testing, software sustainment. Sometimes it's called software maintenance. Sometimes it's called software evolution. Here it's called software maintenance. The cross-cutting skills on the other side are software process and lifecycle skills, software systems engineering skills, as software is becoming obviously more and more, if not the main dominant component of the various modern systems. Software quality, software security. Obviously, security is a predominant and increasing skill set which is required. Software safety, the same thing. Software safety is becoming more important, and as systems become more critical and used in more critical contexts. Obviously, one that's very important if you work on any project that's larger than the one person working on it, which is software configuration or software configuration management, version management, and change control and deployment and so forth. Software measurement, which is obviously cross-cutting to the other to the left-hand side, since it can be used in all the left-hand side skill areas, or in fact all the right-hand side skill areas as well. And human-computer interaction, which obviously is always it was important in 2014 and is of increasing importance now. Next slide, please. For each of these skill areas, there is a set of references which has been put forth. You'll see on the left-hand side of this slide, in the left cell, we have this number of references. Some of them come from the SWEBOC guide, others not. Obviously, this was published in 2014, so they probably would need to be refreshed. The ASEE&T 2004 is the curriculum 2004 guidelines. The SWEBOC is there, and Uyghurs is the main requirement that is cited for software requirements in the Uyghurs in BT book is the main requirement that is cited for software requirements in the SWEBOC guide. And on the right-hand side, for each of these skill areas, you have a set of skills. And then they will be decomposed into activities in my next slide. So here we have software requirements elicitation, analysis, specification, verification, and validation, which is quite usual for software requirements. And perhaps a combination of two, they've combined two here: software requirements and software product management. So you know, these are skills, and then if you go at the next slide, please, and then these are decomposed into. Eventually, they're decomposed into activities. But before decomposing them into activities, they also specify in the SWECOM competency levels. The competency levels are the following: technician, entry-level practitioner, which is probably what we're looking at in this tutorial today, practitioner, technical leader, and senior software engineer. So I would say perhaps in a very simplistic manner, technicians follow in the spirit or what has put forth by the SWECOM. A technician follows instructions. An entry-level practitioner assists in performance of an activity or performs an activity with supervision, coming out of school, for example. A practitioner coming out of an undergraduate program. A practitioner performs activities with little or no supervision. A technical leader leads individuals and teams in the performance of activities. And a senior software engineer modifies existing methods and tools and creates I would say, and creates new ones. So a senior software engineer modifies existing methods and tools and creates new ones. So sort of as a guideline to perhaps better understand what we're talking about, an individual who is deemed, according to SWECOM, deemed competent at the technician level to perform the activities in one or more skills or skills areas would have some kind of advanced education, perhaps a 2-year, in the US context, a 2-year associate's degree or the equivalent in Canada or equivalent elsewhere. I can tell you that in Canada, probably that would be in my part of Canada, probably something like a community college diploma. 1 or more industrial certifications and any number of years of experience. And then an individual who is competent as an entry-level practitioner to perform the activities in 1 or more skills or skill areas would probably be the target that they were looking at would be the graduate of a ABET accredited software engineering degree, so a 4-year degree program in the context of the United States or Canada. Could be obviously different elsewhere, and from 0 to 4 or 5 years of relevant experience. That's what they're looking at. A practitioner level, that would be somebody more senior, perhaps would have a professional master's degree in software engineering and more than 5 years of experience. So this is what, so we're in our exercise, we would be looking, since we're probably an entry-level practitioner. In addition, there are following notations which are used, which are follows, assist, participates, leads, and creates. And you'll see how these are used in the next slide. So if you go, and there are pages and pages of this in this SWECOM. So here we are in the skill area software requirements. Within the skill requirement specification, we have this series of competency levels from technician all the way to senior software engineer. And there you have the specification of activities which could be accomplished, which these different levels of competency levels, persons having these different levels of competency levels should be able to perform. In some cases, for example, the third one, it says PL, so it would be either the P would be means participates or leads. It would depend on the scope and on the complexity of the system on which we are working. So this is what's available in SWECOM. I'll talk briefly about other initiatives in the following slides. Next slide, please. So as I mentioned earlier, there are numerous competency frameworks available, and in industry, this is a very big thing. Perhaps you are familiar with some of these or many of these. So some of them that are available and that have to do with have incorporated software engineering skills with them. The first one is known as SFIA. It's very, very well known. They are now what the current available version is SFIA 7. They are working on SFIA number 8, and it is a skill and competency framework. Also has you know, proficiency levels or competency levels. These different frameworks have differing terminology, but we're always discussing similar concepts. And the SFIA is available in different languages. It is not only for curriculum design, it is also for and the entire skill set, the entire different competencies and that one would need across your entire career, and not only for software engineering, but across all of computing in general. It is British based. The second one, and there's a number of Europeans, I believe, on the call today, is European based. The Europe has one, and there's the one coming out of Europe and one coming out of Great Britain, as in other things in the world as well. The second one is called the European e-Competence Framework. It is a European standard. It has very similar. Discusses similar types of things, not necessarily organized exactly in the same manner. Also covers the entire computing field. Also has different levels of proficiency. Also covers you know, not only for curriculum design, but also different career levels, different levels across someone's entire career. There is one coming out of Japan, which I'm not very familiar with. It is cited in the CC 2020 document. I think it has similar goals called the I-Competency Dictionary. And there was one published in the United States, made available in the United States in 2012. And it is cited in SWECOM, and it is called the US IT Competency Model. So there's all kinds of initiatives that are out there. In other words, competencies are, as John mentioned earlier, especially in industry, they are a big thing, and they are watching this very carefully, and they are using quite heavily, I would say, these various models. Next slide, please. Very briefly, on the next for a few minutes here, I will discuss briefly how I would use a set of competencies that would be put forth for a software engineering undergraduate curriculum at my engineering school in Montreal, and my first usage of it, my first one, because we do this every day, and we are certainly very much involved in this, and is using it in the context of our Canadian engineering accreditation system. So Canada as is the US and the UK, we are signatories of something called the Washington Accord, which enables graduates, which facilitates mobility of professional engineers across different countries. And therefore, the Canadian Engineering Accreditation Board has to meet a certain number of criteria which are put forth in this Washington Accord, and especially something called graduate attribute. Next slide, please. This is the list of graduate attributes, and this list is prescribed in the document. We have no choice. And it's very, very similar to the list of graduate attributes which is put forth in the Washington Accord. Next slide. And for each of these attributes in the Canadian engineering criteria, we must have a set of measurable, documented indicators that describe what students must achieve in order to be considered competent in the corresponding attribute. These indicators are not defined in the engineering criteria. These indicators are defined at the institutional level. in my case. They're not defined at the Canadian level. Each institution defines them locally. This is the set of 3 indicators that I have taken for 3 different, one indicator for 3 different graduate attributes. I've included them and translated them and included them in this slide. We then have to, we then have, as I mentioned, these indicators are established at the institution level for all engineering programs. This is the choice that has been made. At my school, we have a set of common indicators for all engineering programs, mechanical, software, electrical, so forth. They can be replaced and others can be added as well at the program level. If I had an agreed set upon of competencies for a software engineering undergraduate program, I certainly would use this agreed set of competency to interpret these indicators at the course level when selecting assessment tools and also when analyzing results. So, so I would certainly use them in the context of localizing these, very abstract graduate attributes in the context of a software engineering program at my school. This would be my first usage of such a set of agreed upon competencies if I had one. Of course, there could be many other usages as well. Nancy?
Yes, I'm here.
You're on.
Okay, next slide. Well, I often say that my career has been a series of accidents, and my involvement in CC 2020 was no exception. I decided to go to a conference, Frontiers in Education, and the primary reason was that it was only about an hour's drive from my house. While I was at the conference, there was a session on CC 2020 that involved John. And he said, well, gee, Nancy, why don't you join this task force? Shouldn't be too much work. And lo and behold, I suddenly ended up chairing a subgroup to develop the software engineering draft competencies. It was a lot of fun, took place a couple of years ago. And we duly sent our competencies in where they got massaged and added to the document along with everything else that was being developed. I know that all of you are interested in software engineering, so that's what we're going to be discussing right now. Next slide. So in the draft report, which is a pretty long document, but is available, we know that software engineering is an engineering discipline. Let's emphasize the term discipline. So what's different? First of all, the idea that software engineering is a discipline, which not everybody understands just yet. That relates to the next item on this slide, that people who have a software engineering job title may or may not have a degree in software engineering. They may not be doing what we would consider software engineering. If you look at job descriptions, they are often basically looking for people who know a particular programming language, have a very specific skill. And even though they're called software engineers, they may be doing just one activity that we would consider to be part of software engineering. If they are trying to really do software engineering with that discipline, they may or may not have a degree in software engineering. They might have a specialization within another program, such as computer science or computer engineering. If you are in other countries, it may not even be called software engineering. It might be part of a larger umbrella term, such as computing, which I know our colleagues in Europe use very often. And some years ago when I was in Australia, software engineering had a different meaning altogether. Next slide. So the competencies drew on many sources, and we had folks involved in it. The list of people in my little subgroup included both task force members for CC 2020 and other people that I managed to recruit, similar to the way John recruited me, I might add, who had a lot of experience in curriculum design. You'll see their names in the material that's included in your background material. Pages 12 to 14 lists the software engineering competencies and also all of the subgroup members who were involved in developing them. So they reflected not just prior curriculum development experience, but also the firsthand knowledge of the subgroup team members. People that were involved had worked on Master of Software Engineering curricula. In some cases, the original one back in the late 1980s, and in other cases, the update that was done under the leadership of Art Peister at Stevens Institute of Technology much more recently. And then we also looked at software assurance curricula. I led the development of that set of documents. The software assurance materials are all available on the Software Engineering Institute website. If you don't easily find them and you are interested in that, you can contact me and I'll be glad to point you in that direction. Next slide. Great. So this looks very familiar if you were recalling the slides that Pierre presented a few minutes ago. Most of them correspond to the areas in SWECOM. There are only 2 additional ones, project management, which is called out explicitly, and then thinking back to John's material, we added behavioral attributes as a standalone. That may or may not survive as a standalone in the long term, remains to be seen. But in any case, right now, it's in there. Within each of these areas, there are a number of competency statements. Keep in mind that we were a volunteer group. So the set of competency statements for each of these areas or domains can vary. In some cases, we didn't have anybody to expand them at all. So they are a little bit uneven. What we'll be looking at today, we think are among the better development ones. And then I would add that while we were developing these draft competencies, we did not have the benefit of the cluster that John showed us earlier. And that's what we'll be working on today. Next slide. Great. So here's a detailed example. And you might recall in John's portion of the presentation, he had a cluster for one of the draft competencies from software requirements. There are a couple of examples in the background material that you will need to download before we go into our activities. And software requirements is one of those examples of a cluster. In any case, we have 5 pretty standard activities that are involved with developing software requirements, but it may not be complete. We tried to use standard terminology. So each of these competency statements was constructed in a particular way using particular terminology. So you'll see on the first one, it's identify and document, and then applying a known technique, using facilitative skills as a contributing member. The second one, maybe a little more serious, analyze software requirements for consistency, completeness, and feasibility. Recommend improved requirements documentation, again, as a contributing member of a requirements team. And so on, to go through a standard set of software requirements engineering activities. Next slide. So there are 5 of them. And these are the remainder of the 5. So that's software engineering requirements. There are 5 competencies, 5 draft competencies. Each of those could have a cluster similar to the cluster that John presented, where you have the domain name, software requirements, you have an individual competency statement, and then you try to relate it to source documents. We find that this is very useful to people who are trying to do curriculum design and certainly accreditation. Next slide. Here's another example. This one is near and dear to my heart and came in part from the software engineering, or rather software assurance curriculum work that we did a few years before that. And these are focused on software security during development. So this is not about virus detection. It's not about response to a break-in. It's not about information security operations. It's about how you develop software that is more secure to begin with. And the set of competencies that you see here are related to that. So we've got 4 initially. Apply a selected security lifecycle model, identify security requirements, incorporate them into architecture, high level and detailed design, develop using secure coding standards. Next slide. And et cetera. The standard software lifecycle activities, testing, continue to use the software development process, whatever it may be, and then develop software that supports the project's quality goals and adheres to quality requirements. We think that quality and security are closely related. You could have a similar set of competencies, maybe not identical for safety. The safety area had work that preceded security, so it's a little bit more mature. Next slide. And finally, here's project management. This is different, and it's focused on managing a small project team rather than being, for example, a program manager on a really large project. And this is something that is perhaps different or orthogonal compared to some of the other documents. Next slide. So with that quick overview, we now are in a position to do 2 things. One is to answer any questions that you might have on everything that you've seen so far. The best way for us to handle this is to post those questions in the chat session, if you have any, and also look at the chat session for how to download the documents that we're going to be using in the next set of activities. We need you to do both of those. Put any questions on anything you've seen so far into the chat session and we'll answer them, and then download the documents. I know you're there because I can see some of you. If you don't have questions, that's okay too.
We only have 13 people right now on the call. So if you just have a quick question that you'd like to ask, I don't want to abuse protocol, but it might be easier that way. If not, we'll just move on. You could always ask a question later. Okay.
We have a question.
Where's the question?
Okay, good.
It's a comment from Gerhard.
Yes.
says there is no product management. I just gave a talk where I said it should be used. That is true, and I sat in on part of it.
Yeah, I'm a little bit, yeah, I just said in the previous talk that I gave together with a colleague, we are not in project management in the IT. We are a lot more in product, we are in product management because our software is never finished and there are no projects. So project management doesn't make sense, in my opinion, for 90% of what we're doing in IT.
Well, personally, I think that's a good contribution and something that should be visited. I might add that there's nothing magical about the list of competencies that we've come up with. It's more of how you would develop them and use them as opposed to being prescriptive guidance. And I think John and Pierre would probably agree with me on that. I would also offer that there was, I don't know if you might have been on distribution, there was a pretty extensive comment period on the document.
I'm from industry, not
did
from
try to address them.
University. So for me, it's the first time that I see it. So
John, perhaps I could say something. This is Pierre speaking. I believe you're right in the IT field. In not all cases, but in very many cases, doing product management rather than project management. But that's necessarily true across the entire industry and not across all application domains. I think it's not necessarily as true in other application domains. And in other cases, if you're doing outsourcing, perhaps or you have to do work in government and you have to do subcontracting and so forth, project management would remain, I think, still very important. But that doesn't mean that product management is perhaps something that we should add. But these models try to be as generally applicable as possible.
If I also may perhaps do some cultural translation here, if one permits me. I do have there's two observations I'd like to share. One of them is that from my perspective, over the years and the years that I've been in Europe and worked in this area, I've never really noticed how the ACM, IEEE, or ABET, or any other curricula, I'm not sure what the plural is. I don't know. They don't really play big of a role in Europe, or at least in Germany. They seemingly they don't observe. Some people know them, but not many, and such things. So in general, it feels like in Europe it doesn't play as big a role. I'm not saying it shouldn't, because in my opinion it should. And ever since I came to the US, I felt that these documents and these efforts have some very clear guidance for us and do provide a certain level of standardization in industry where some is often missing. And another thing that I would also perhaps comment on is that I think the role of a software engineering curriculum in Germany seems to be somewhat different from a software engineering curriculum in the US. In Germany, it seems to me that most software engineering graduates become, I want to make a complete statement like this, but it's almost as if they're becoming more consultants as opposed to software engineers in a company, even if they're internal consultants. But it seems to me that if they're going more towards consultancy, there seems to be a bigger influence or a bigger role in project management, something that I don't necessarily have seen in the US. In fact, what I have seen is very much resonated by what Nancy said earlier. Most of the jobs that I see my students go into are exactly what Nancy said. The companies are saying they're looking for a software engineer, but they really just mean PHP code monkey or something like that. And so I think that's a difference between the US or North America and Europe, at least, or Germany.
Well, with the CC 2020 project, there was a big problem with nomenclature. what is considered informatics in one place is IT in another place. The vocabulary is not consistent across countries. And so that's very difficult. Some people think computer science is everything about computing, but we call it computing in the CC 2020 report. So the use of language is a problem, and that's why we tried to make the CC 2020 project as global as possible with 20 different countries from 6 continents. So let's see, I think we need to move forward a bit so we could.
Yes.
Yeah, did everyone download the documents?
John, I've got the microphone. You can relax.
Okay.
Okay, so next, good. You're in a good spot, Marie. Go to the next slide. So I'm going to go over the basics of the instructions. And yes, you need to have downloaded the documents, especially the background materials. And there's a worksheet that you'll need in order to do both activities. The worksheet comes later, but the documents, the background info for sure is needed now. So what we're going to do is Marie has created breakout rooms, or we'll do them while I'm talking.
Yes, it will take a few seconds before everyone is assigned, but it should work.
Okay, and what will happen is you will be randomly assigned to a breakout room. When the invitation appears on your screen, go ahead to the specified room to meet with your team members. At the end of the activity, the work session will automatically terminate and you'll be brought back to the main Zoom session. If for some reason you need to leave the breakout room, but you want to still participate with us, then make sure to only leave the room, not the meeting. At the end of the activity, we will all come back, and during the breakout session, John, Pierre, and I will each visit a room. You can also signal for help if you get stuck and none of us are there. But right now, what we want to do in this first breakout session is for you to familiarize yourself with the competency cluster idea. Later on, you're going to be developing competency clusters yourselves. You'll recall that John briefly mentioned a competency cluster. You'll find 2 of them on pages 9 and 10 of the background materials. And then, Marie, once you're able to, the next slide is to read those 2 example competencies on page 9 and 10. And these points also appear on page 11 in the document. So read them and consider. Do you nod your head in agreement, or do you shake your head trying to figure out what the point of those competencies is? Are they written in a consistent manner to one another? How well do you think they relate to the SWECOM material presented earlier? So these are just ideas for things that you might consider while you're reviewing those 2 competency clusters. And each one will look like a domain name, below that a competency description, and then below that the references that appear in each competency cluster. Has everybody got that?
Yeah, should we allow about 10 minutes for this? We're a little
yes,
behind.
I think 10 minutes will be fine.
Let's make it 15 minutes, just so I have enough time to read all the material and then, brain, and then
that's
assign a leader.
I'm fine with with
Okay.
We're a
15.
small group, so I think we can extend. There's not 50 people on this call. So
Yeah, they're only, that's why, so.
And thanks for Pierre for adding that. Please do appoint a leader so that when we get back together, one person can report on your findings.
I have sent all the invitations, so you are now able to join each room.
Please do, and we'll be doing the same.
Okay,
See you later.
in room 3.
Marie, both Pierre and I were assigned to the same room.
Okay.
So
I will.
John, I believe, is in room 3.
Okay,
So
so
you need to put me into room 2.
Okay, I'll put Pierre in the room 2. Okay, are you okay? So Pierre has left.
Oh, okay. So I guess I need to go back to room 1.
Yeah.
I don't know how to do that. Let me see. All right.
You
Okay.
are, yeah.
Bastian, you owe me a coffee or something.
Okay, I'm back.
Everyone has the micro off.
Did we succeed in confusing you?
Yes.
Oh,
totally.
good.
Yes. There was one instructor and one student, true?
Yes, that was my room, yeah. Was I supposed to leave, Maddie?
Yeah.
I was in room 3. Was I supposed to leave? I only left when I was told to leave.
No problem.
Okay.
Everything is okay.
Everything.
Yes, we had exactly 3 rooms, John. One of us was assigned to each room.
Okay, very good.
Yes, Maddie has a lot of power, and she forced me into another room.
Well, only Elko was in my room, so, but I don't know where she is.
I used to be her boss, so now she got retribution.
Oh, okay.
Okay, so let's go on to the discussion. Presumably, do we have 3? Well, I guess in one case, the team lead and the team members are just about the same. But can we get a report back from each of the team leads and whatever questions or comments you might have had?
Why don't you go, Gerhard, in our group? You had a lot of concerns, I would say.
Yeah.
Put it this way, I think you were surprised at what you saw.
Yeah, I'm not really getting and grasping it, I must admit. But when I have a look at it, I'm not really sure that it fits my mental model of how at least individual software development is done from my background from industry. So I don't really see that this is the way of currently working together using these terms and using that kind of approach. So for me, it's not fitting. Not my opinion of how product management should be done, software engineering is done. I wouldn't suggest having different roles for software testing and software developing, at least in small teams and so on. So I'm not really grasping what you're after. I must admit, sorry.
Well, this is more for curriculum, for undergraduate curriculum. And if the 56 competencies that Nancy had accomplished with her group 2-3 years ago, basically it represents all of software engineering. So if person was able to do all of 56 things, then the claim is they're competent to graduate with a 4-year degree. For example, computer engineering, they worked hard at it. They reduced everything to 24 sentences. So the entire 4-year education for computer engineering is summarized in 24 sentences. The alternative to that with knowledge-based learning was to create learning outcomes for each topic area. And if you go back to the curricular reports, there were maybe 800 to 1,000 of these, okay? There's no university on the planet that could accomplish the 1,000 learning outcomes associated with the curriculum that they proposed. So that's why we went to the competency-based thing. So you could reduce things to smaller areas. But I don't want to monopolize this.
So what I think is you have to have some experience in doing things because you need the you need the possibility to dive into complex things, in my opinion. And in my company that I co-founded about 20 years ago, we can integrate people from different backgrounds in a few weeks, I would say. So I'm not really sure if in the industry on the practical level, and you need all of that. And I would say mostly you even don't understand these things until you know that you need them. So there's a lot of implicit knowledge that you need to be able to work in the industry. So, and most of the stuff here is, I'm not sure, it's just probably too detailed. I'm not sure.
All right.
So learning by doing is something that I consider the way to go. And I'm not sure if this is applicable or convertible to what I see.
Well, that's what
probably I should just be a little bit more quiet because I'm from the
No.
industry.
I mean, that's the whole idea with that the CC 2020 project and also SWECOM, I believe, was trying to do, is to enhance the skill portion part of knowledge, okay, and then being able to fit in a particular situation. So you have to have those attributes, those human attributes, you know, like time management and things of that sort. But I mean, that's fine. You have very good opinion.
So perhaps the other item I could add very briefly is that there was a bit of confusion because don't quite understand how to do this. So I'll be very brief. So, you know, in software, this was a we looked at the software construction statement, and we had put some things that evaluating and applying, and I'll go very specific. Software configuration management, we had put it understanding. But on the software configuration competency statement, you would probably put it higher. You would probably put it at applying. So at the end, we're putting here at understanding, but at the end, the graduate will have a higher level of competency to be able to meet the software configuration management competency statement. So there was a bit of not a conflict, I would say, or a contradiction there.
All right.
For example, if you want to use Git, it takes about half a day of basic understanding of Git so you can use it. Yeah, half a day. I think that should be enough just to be able to commit something and to be part of a team. On the other hand, if you really want to get deep into configuration management and really to understand why this kind of working is helpful and how you probably tweak some things, it might take years to really be a master of that. And the difference between half a day and some years is huge. So
and lots of money.
Yeah, you need sometimes just a super guru to be able to reverse some things. If you use Git, you can shoot yourself completely into small pieces with Git if you want to, just to have an example. And you need this superhero then to get you back together. But still, you have to be able to use Git if you want to create software nowadays. If you can't do it, you're just...
Okay. Let's go to another opinion, another room. Because then we're going to take a break in about 5 minutes. So
allow me, if no one.
Okay. Were you room 2? Bastian, were you room 2?
I was room number uno.
Oh, uno. Okay.
Yes, and what we have filed over this template quite a bit, and we were somewhat confused by 2 items. Firstly, we noticed that these dispositions seem to be fairly vague. I mean, I like the fact that they are written as adjectives, whereas everyone else used to be a noun, so that was helpful to some degree. On the other hand, we felt that the word professional was in both competencies. It was there, but you know, don't you always have to be professional? It's the one thing. And Dennis in particular was missing. We specifically looked at the requirements one, and Dennis noted that you know, it should really also be adaptable, right? You as a professional should be adaptable to the situation in order to maximize your requirements, engine elicitation, and negotiation ability. So that's one thing we both agreed on, and with Nancy's guidance. The last thing we noticed is that there seemed to be some overlap in the top portion of the template and the bottom portion of the template, in the sense that it said from table AB, the knowledge areas, and you have the competency, the skill levels. That seems to be summarized in the SWECOM elements in the bottom part where it says E, table E, right?
Right.
So it felt to me, or it felt to us, that the bottom part really was a repetition of what was already there in the top part, which, you know, you could argue it makes sense if you're developing a curriculum and you're looking at different things, different parts of this at the different time. But, you know, if you understand the idea of what, you know, knowledge and a skill is, like understanding and being skillful, understanding, and then the overlap of that is the competency. I guess when you understand all of that, you don't need the table E part.
Okay.
That's what I
Let me
would gather
just
from that.
give you a background on the CC 2020, that list of 11 dispositions. You might say they were just, I don't want to use the word arbitrary, but because they were meaningful, but I don't think they have to be forced upon any one discipline. Remember, it was like a framework. You may think, and I even mentioned in the presentation, that there should only be 8 of them, or there should be 12 of them, and you can pick your own words. These are the attitudes for the different disciplines. For example, information systems will probably want to gravitate to a set of dispositions that are not exactly the ones that software engineering might want to do. So if you were going forward with this, you would say, we like some of the dispositions and that were given like in table D, but we think these are more appropriate. And that's certainly allowed, you know, I mean, the CC 2020 is just a suggestion, a guideline, a framework. If you go forward with this, then you know, it's a you can make your own constructs.
Okay, understood. Thank you.
On your second point regarding table E, I would say that's more for coverage, making sure that, you know, and eventually table E, I assume, would disappear, right?
I was wondering about that. Having just recently suffered through ABET accreditation, and I'm using that verb specifically because it was an ordeal, and it was also it didn't improve our curriculum in the least. In fact, we tried really hard to maintain our curriculum at the high level that I claim it is, despite what the ABET reviewers tried to do from us. But having just suffered through that, I had the impression that this might be a coverage thing, like an assessment thing.
No, I don't think it's not in the sense of assessment, just in the sense of coverage. You know, this is work in progress and coverage, not.
Oh, okay. Well, I was going to say, if you cover something, if you want to cover something, you have to measure how much you covered it, right? So that's why I said
no, just making sure nothing is forgotten. That's all.
Okay, understood. Thank you.
Gerhard, did you want to add something?
Yeah, I think I found my mental model problem, and I want just to share a small picture. And I think I'm on the lower part, and I think you are on the top part, where things step by step belong together to be some perfect stuff. And I think just learn moving, yeah. And you can improve that with more speed, with more power, whatever. And what I saw is a little bit more different parts that probably you have to go till the end to 4 to be really understanding what the output result will be. And I'm not in that. And that's probably my misconception about it.
Okay.
So are we the top part, Gerhard, or are we the bottom part? We are the top part?
I thought, for me, it felt like the top part.
Okay.
Okay, let's go on to the remaining team. We should have one more team or person.
Yeah, Elka from room 3.
Room 1 and 2 already covered. Okay, so I was the team in room B, in room 3. So I had to work with myself. There are people who say there are 7 persons in my brain, so I quite could manage that. But one of them should be the team leader, and I don't know who that will be. So, it was quite a good discussion with John, And well, the problem is that I'm also from the European landscape. So I'm teaching software engineering in an IT bachelor study with study program with different programs, and I have to teach everybody in these different programs. And I'm doing software engineering for all of them, including well, processes as well as skills, as well as analysis and design methods. So I'm also teaching UML in just 4 hours for the whole study. So well, I just try to get the best of it, the best of software engineering in my classes. So what my favorite example was, it was that one about requirements, software requirements, because I'm also doing some stuff in requirements engineering, and there are maybe some skills levels I think there should be on a higher level. For instance, verify and validate the requirements. If you verify and validate requirements, you should also know more about software design, for instance, not just understand it. If you require something from other persons to do, you should at least know how they do it and what they're doing. So also as a project leader, I try to not overwhelm my team members. I don't ask more brain work, more output than, or better strategies or better time than I am using, or I used in my state when I was on their level, you know. So I think there are some just understanding is in some knowledge elements maybe too basic regarding the skills level. So that's just from my personal point of view in the field of requirements engineering. Regarding construction, I cannot contribute much in this respect.
Okay. I think, though, Elke, it's very similar to what Pierre had mentioned with the SWECOM. You know, you have the technician level, they just follow, they don't do anything. And there's a correlation between that and someone who just perhaps understands or remembers, you know, certain aspects. In the knowledge-based case, we basically ask students to remember things so they could repeat them on exams, which doesn't seem to be the way, at least the way I've been researching it, the way industry thinks it, because industry tends, and Gerhard, you contradict me if I'm going off track here. Industry wants people to be able to be skillful and also be able to, you know, join and be part of a team and, you know, to fit within the corporate environment. If they're just going to graduate school and you're going for their master's and PhD, then it probably doesn't make that much of a difference. But since most of the students who graduate go to industry or government, that's the motivation for trying to push the competency part. Anyway, I don't want to take over the time. Nancy, did you want to add anything else?
Not to this. We're about to take a break. We will take our 10 minutes. My suggestion is that you not leave the meeting, but maybe mute and silence your video. And Marie will put that break slide up in case somebody would try to join while we're gone. That would be wonderful. So 10 minutes, and we're all in different time zones, so we have to time ourselves. See you.
Okay. Marie, could you put it to the break part?
Yes, okay.
Yeah, you have it on something else, discussion. Yeah.
No.
Thank you.
Well, okay.
Bastian, are you there? I guess not yet. Okay.
What's up, John?
I'm waiting. Are we all here? I'm not sure if we're all here.
No, I was still on break. I didn't know if you had some urgent question.
No, I didn't have anything. A few people had to drop off.
By the way, we don't get automatically cut off. So as long as people want to talk,
yeah, sure.
At the end of this, we can do that. But I think with the smaller group, that may or may not be necessary. So I'll be back momentarily.
Sure.
Dennis, I have a question for Dennis. It's 1 o'clock in the morning where you are. So you have a particular interest on this specific tutorial, on the topic of this tutorial, and perhaps at your school or?
Yes, we kindly use computer science curriculum 2013 in our curriculum plans. So it's quite interesting for me.
All right.
And what is the, okay.
Yeah. No, go ahead, Pierre.
And what is your curriculum at your school? What's the program? Software engineering, computer science, informatics?
Bachelor of Software Engineering.
Okay.
Okay. If you look at CS 2013, which is a 500-page document, it has about 1,000 learning outcomes, which no one really could fulfill. So, so the whole idea is to try to reduce this to meaningful, accomplishments, but through these competency statements. All right, we probably should start. We're what, 9 people on the group now? Okay.
Yeah, Gerhard had a temporary.
Yeah, he had a family
issue. So we'll go ahead with the, Marie, the next thing we come to the instructions for activity 2.
Do you see it on screen presently?
No, not yet.
Not yet. Aha, here we go.
Now, do you see it? Yeah, okay.
Yes. Okay, so for the second activity, we're going to practice developing a cluster from some individual competency statements. So just like before, you'll get an assigned breakout room. You'll be sent there and then transported back. I think we allowed 30 minutes. If we find we don't need that much time, we can come back early, and Marie can keep an eye on that for us.
Yeah, I have a comment. We didn't know how many participants we would have, so we had planned on 6 topics, 6 domains.
Yeah, just change
because there are less.
Marie, just make 3 rooms, and it doesn't matter which ones. Can you do that?
Okay, very good. Yes, certainly. Okay.
Yeah.
Okay.
Since it's a random, thanks. Since it's a random assignment, you might not have the same team members, and between Marie and Jean-Pierre and I will try to make sure that we're the 3 of us are in different rooms. So the names of the areas or domains will be the same as the names of the rooms that you're assigned to. So take a look at those when you get the invite. Pick a couple of competencies from the list of competencies in each of those areas, and then go ahead and try to create a competency cluster or two. You can pick one from each area, or you can pick two from a single area. If they're not your primary areas of expertise, don't worry about it. It's for practice, not necessarily something that will survive permanently, or although if they're really good, they might indeed survive permanently. So you'll need at least two more things. One is there is a worksheet for you to fill in for each of these clusters. That is one of the documents that was there for download. And then at the end of it, send those completed sheets to Marie and she will display them for the discussion period. Okay, does everybody have that? All right, then.
Again, on the time. So the time, Nancy, do we really need a half hour?
Maybe 20 minutes. What do you think?
Yeah, probably 20 minutes would be good. And I think the discussion is actually
it's more interesting than
filling out a Word document.
Nobody likes to hear everybody else. They don't want to hear us talk forever. So that's quite understandable.
All right, 20 minutes would be good. And then we come back and talk about everything. Okay.
Right. And if it's not automatic, we can use discipline and come back ourselves. So you should each have an invite on your screens.
Okay, goodbye.
See you.
J'étais tout seul, Marie.
Oui. Je vais vous déménager avec Nancy parce qu'il n'y a pas assez de participants.
C'est quoi les sujets? Moi, je dois choisir mon sujet.
OK. Ben, il y a software design ou bien software qualité.
Envoie-moi dans software quality.
OK, parfait.
C'est avec qui?
Vous allez être avec Bastien, John et puis Marianne Dawn.
C'est bon.
OK.
Il devrait avoir une invitation bientôt. Là.
Ben, ça devrait, là, parce que c'est parti. On va être pressé.
Es-tu sûr que tu l'as activé?
Oui, je l'ai activé, là, je le vois. Là. Vous étiez dans le software construction, puis là, c'est juste marqué not join.
Peut-être qu'il faut que tu supprimes cette salle-là, peut-être, parce que sinon, il va me...
Peut-être. Je ne sais pas si pendant que je suis en train de faire ça, j'ai peur que ça va fermer toutes les salles. Un peu là. Mais pourtant, vous n'êtes plus là. Vous êtes sûr que vous n'avez pas un message quelque part?
Je vais... Ah oui, je l'ai ici. Oui.
Ah, OK.
Il fallait que j'ai cliqué rejoindre, je n'avais pas vu le mail.
Ah, pas de problème. Bon voyage.
Hello, I was thrown out of my room.
Me too. Now we know who's really in charge here.
Yeah, Maria's in charge of everything.
Yeah.
She's enjoying this. She has a big smile. You know?
Yes.
Have you sent me your file through my email?
We did not have time for that.
Okay, good.
So my group
what you,
sent it.
What
Yeah,
you can do?
You could finish it up and then send it to her. Yeah, that way she
or
can
maybe you can share your screen and then we'll see what you've done.
It's a small group here. We can share the screen, and at the end you can send it to Mehdi. It's not as if we're 50 in this workshop.
Right.
Okay. All right, why don't I? Hold up. Bam. Here we are.
You want to go, Bastian?
Okay. Well, I mean, we didn't do all the work. So I feel like I shouldn't be presenting this, but okay. So
you only get a C grade or an incomplete, but it's okay.
That's okay. I can live with that. So it's like getting a C grade on a general. Never mind. So we were in the room, software quality and /or safety, and so we took the first statement from the top, which was the first in the list was quality. So we took the first statement, which was this, and then we looked at, okay, so well, we did the things, we copied the statement there, and then we tried to fill the rest here out. And immediately from the gut feeling, we felt like the first important thing should be evaluating and software quality, because the two examples said the topic that was also in here needs to be evaluating. So we like that was the pattern we followed. And then after a little bit of discussion, we decided that requirements is definitely necessary, and we left it at the skill level of applying. And Pierre suggested we should also perhaps need systems engineering and design, as well as process lifecycle, which we didn't get around to write down. And then we took a very close look afterwards at this statement here, and we try to pry out the different knowledge elements, I guess, that are mentioned here already, and repeat them here. And then we realized, or Pierre suggested, that they should also all be understanding, and I don't really know why. I'm sorry.
So if we look at the verb here that says distinguish, there's nothing in the competency statement about evaluating or applying. It's about distinguishing quality attributes. So we're a bit, but then if you look at the, I would say the major, I'll share my screen here.
Let me unshare.
No, I think I can. The major, I would say, conclusion we came to is we looked at the list of competency statements in software quality, and they seem to be written in an incremental fashion, beginning with understanding here, then perhaps the second one is applying, then perhaps the third one is applying. The fourth one looks like we're getting into more evaluating, and the fifth one maybe is something else. So we said, okay, it looks as if they were written in an incremental fashion for software quality, and we sort of, well, since we're trying to specify the competency statements at the end of the program for the graduate, why do we bother with the earlier competency statements, which are at lower levels of competency? Because they will be subsumed later by subsequent work in the curricula. So that got us a little bit lost there. Did you follow me?
Yeah. So are you suggesting there should just be one competency statement for software quality?
Maybe not more, maybe more than one, but this one, which seemed to be a prerequisite perhaps to some of the later ones, then if it's a prerequisite and the later ones are achieved, why is the prerequisite still there?
Maybe
That's
these are not written in a priority order or anything like that.
And that's how far we got in our analysis.
Okay.
Nancy, does that make sense?
Yes.
And I came.
And I don't recall off the top of my head. I don't recall how we came up with these 5 or.
Yeah, and I came to the conclusion that Bastian asked, you know.
Yeah, I think we'd have to go
was
back.
this analysis useful? And I said perhaps yes, because the fact that we tried to build these clusters perhaps enabled us to come to this conclusion, and perhaps just by reading passively these competency statements, we would have not come to the same conclusion. And
I think
maybe that was useful.
Maybe it's worth noting that we did a whole bunch of background work that didn't end up in the final competency statements. And so there may have been some justification that is captured elsewhere that doesn't appear in the statements. I would have to go back into my old files to see exactly what might have transpired, because each of these domains or areas was a little bit different depending on the volunteer or volunteers that were working on them. And we developed a whole lot of material that didn't make it into the final document because it didn't fit the format. So there might be some justification, and it might suggest modifying some of these.
Oh, absolutely.
Then again, there might not be any justification.
Yeah, back then we did not have any elements of disposition. We did not have any elements of skills and how they would be applied, or elements of knowledge, as we call professional knowledge, or even the software engineering knowledge, other than the SE 2014 document in SWECOM. So now we have something, whether you like it or not. If you don't like it, you could change it. So if you don't like, again, I'm repeating, if you don't like the disposition list of 11 things, make up your own that are more appropriate for software engineering. So the whole idea is to come with a structure so that if you have to write a competency statement, you reflect and say, well, we need knowledge, we need skill, and we need disposition. How do we put it together to convince something? But anyway, I don't want to take any more time on that, but that's
okay.
Nancy didn't have that 2.5, 3 years ago.
Right. So let's see, I think that we're now ready for the team that I was with. But Marie, you should have that document. If not, we'll do the screen share.
I will show it in a few seconds.
No, that's all right. Dennis, maybe you could do the screen share.
It's opening right now, so.
Oh, okay. All right. And once we've done the screen share.
Unfortunately, what I see is it has not been, I don't know if it has been completed. I will try to share it.
Okay. It should be the whole template.
Yeah, just a minute. Now, do you see it?
Not yet.
Not yet? Okay.
There we go.
There we go. Eureka.
Is the information present? It seems like blurred a little bit.
Yes, I copy-paste from the PDF file, and I guess style was not changed. It's filled it's just filled with gray color.
Okay, perfect.
No.
So we'll have to focus sharply.
Could you make it larger? My
Yeah,
eyes.
this is what I'll try.
Okay.
Is it better now?
Yes.
Yeah, it's getting better.
Okay, good.
Okay.
Okay.
Okay. I'm not going to present it. I'm going to ask my illustrious team member to do that.
I guess so. We choose software. No, we not choose software design. Choose us. We choose third competence in list of software design. Produce detailed designs for clients for specific subsystems. High-level design by using design principles and cross-cutting aspects to satisfy functional or function requirements. We start to look to knowledge elements. Of course, software design should be the first one and should be at very high-level skill. For doing work related to this area of competence. Then, because it's related to working with requirements and working with clients, we need to put software requirements and also in very high skill applying. Then we're talking about software construction because we need to design our system. It should be analyzing software quality because we need to predict what will be happening in our software in the future. And also software process lifecycle, software security and understanding level, because you need to be aware of this when you're designing your system initially for the client and high-level work areas. If you're talking about personal skills, it's the same, quite the same for any architects: analytical, critical thinking, problem solving, troubleshooting, multitasking, prioritization management, collaboration, teamwork, research, and self-started learner. Last one we add, just in case if your system very unique and you don't have any ideas about how this type of system can be done, and you don't have any persons who can lead you to do it. But we had issue with defining the level of personal skills because it's not quite the same if you're talking about professional skills, professional knowledge elements. Then we choose these positions for 4 of them, which seemed very logical for us to be if you're talking about software designing, and then very related SWECOM skill areas, which should be quite the same as quite the same as skills from table A.
Can you move up, Mehdi, to the top? Can you show us the competency statement? Yes. Show us the competency statement. So my main question would be, this is producing detailed designs, and you've put it as evaluating. So what would be applying if actually doing detailed design is evaluating?
As we get from list of level of those skills, evaluating much more bigger than applying and analyzing. So if you're talking about high-level designing, it should be, I guess, evaluating, because you need to design your system ahead and very high level. And then negotiate, produce, present this you're designing for client and other stakeholders.
No, but my question is producing detailed, the first part, producing detailed designs for a client. So it means actual designing, right?
Yes.
And you put it at evaluating. So my question is, if this is evaluating, what would be applying in terms of design? This is actual doing design.
I guess it's question not up to me. I'm just using the table which was.
Yes. No, I'm posing a rhetorical question to the group, not necessarily to you, Dennis.
We thought that applying is a pre-stage to evaluating, so that you have to be able to apply when you want to evaluate something.
I think, Pierre, one of the challenges is that The concern you're raising requires looking at the definitions of each of those terms and internalizing them.
Yes, I agree.
And clearly,
getting consensus on these, internalizing is the correct term.
And again, those were the ones that appeared in the CC 2020 report. But if you don't like the definition that was used or the word that was used, with software engineering, the framework for doing that is there, but you could change that and give it to your own specific meaning. Because what's in the CC 2020 report is for all computing. So from information systems to computer engineering, and maybe not necessarily appropriate for software engineering. So, but the structure is there where you make this pair between the knowledge element and the level at which you need to apply it or evaluate it or understand it, whatever it may be.
So we would have had to have in our heads table C that appears on page 5 of the background document.
3 years ago, but you didn't.
Yeah.
Yeah. So now we have it. So the question is, how do you justify the competency statement as we move forward and going forward for software engineering? I mean, you did a wonderful job there, Nancy, because you had none of this.
I did. Oh, you mean in developing?
You had none of these tables.
Yes, we were working in a vacuum, so to speak.
Yeah, I know. It's great.
And that is worth noting that the competency statements were developed in parallel with the main body of the document. Or I should say there probably was a draft at that point, but I don't know that it bore resemblance to the final one.
All right.
And I think the folks who are here today did a good job of a great job of trying to understand what we did and actually apply it in developing sample tables.
Yeah, it takes a while to understand, but then once you get the knack of it, it says, "Oh yeah, that's right."
I'm still trying to understand.
I think Gerhard made a comment earlier that these SWECOM portion, table E, seems to be redundant with what's above it. And remember, in the CC 2020, they don't have that last track, which is the SWECOM table. So the question here is, can we take things from SWECOM and can we take things from CC 2020 to justify the competency statement that's there, or should we modify that competency statement? Or start from scratch? I wouldn't suggest that because we already have a lot, so it might be just tweaking what's there.
So what would you suggest to somebody who's trying to use CC 2020?
To look at you're speaking to me, Nancy?
Yes.
Yeah, that they should look at first they have to accept that competency is an integration of knowledge and skills and dispositions. If they don't believe in that, then it's a waste of time, okay? But that comes from medical schools. So we didn't just invent that. There's lots of literature that goes back to 100 years and how medical schools operate to be a competent doctor or dentist or whatever. So that's from where it comes. So now we're trying to apply it to computing, and we're trying to do our own little structure cluster for this, so there's some understanding. So it's not an arbitrary thing. It's just a way of doing it, and people might like the way it is with CC 2020. They may wish to modify what CC 2020 has and do it their own way. And the competencies that are generated are not absolute because they're going to vary, again, as I mentioned earlier, with the culture of the university, the department, the mission, et cetera. So we could come with suggested competencies, but that's probably as far as one could go. So if you're looking for an absolute set, I don't think this is going to do it, but never know.
Okay.
Maybe I can make a little statement
Yep,
here.
go ahead.
I did not hear Gerhard your speech, but this is very much a product management approach, right? But the product is the graduate of an undergraduate degree. It's true. That's what we're doing, right? If you're trying to specify what and I don't know how familiar you are with the university environment, and I believe you are, but our university curricula, we're very, very much, at least in my case, in a highly regulated environment, regulated by the faculty, regulated by the university, regulated by the government, and as Bastien so ably said, regulated by the accreditation authorities. And that's so we can't change. You can't change what we want as easily. So this is very much a product management approach, trying to specify what it is we're going to produce at the end. And internally, we have to figure out how to do it to get across all these, to make sure that we satisfy all these highly complex and conflicting regulations. Did I get that right, Bastien?
I think you did it right on target.
Yeah, I think the problem is that you have so many. The idea of the conflict here is, I think, important, right? Because
the conflict of what, Bastien?
The conflict of, all right. So get this. We were just recently informed, and by recently I mean yesterday morning, informed that now we have to assess critical thinking in our students. And while we do that, we should also please define learning outcomes for diversity, equality, and inclusion. And I'm thinking, okay, sounds great. How is that going to make my software engineers better software engineers? And the answer, of course, is, well, it doesn't, but it makes you a better human, right? So, and everyone should have DEI outcomes, for example, but now I get to change my introduction to software engineering and my safety requirements class, because those are the two predominantly project-driven classes in our curriculum. I'm pretty much the one who's going to be solely responsible for now teaching inclusion and diversity to my students. And I'm thinking, why are you bothering me with this? I should not have to worry about this. It's already hard enough to teach my students what an ambiguous requirement is and what underspecified requirements are, and I need to shake them by the shoulders and to give them an understanding of when they're being vague and lazy, right? When they're just so and of course I understand why we're doing the DEI stuff. I'm just, because when you look at the projects that we're dealing with, one observation I've made just a couple of weeks ago is that some individuals are culturally less likely to, voice their opinion in a project-based and a project team environment. So that's where the curriculum needs to help those individuals, and we change the culture. And I understand that. The thing is, though, these ideas that now I have to do that, they come top down, right? They come top down. They're not competency driven. They're not driven by the industry. They're not saying, hey, listen, Bastien, we will hire your students, except none of them are diverse or inclusive or whatever. It says no one ever. It's a top-down thing. And this is what I'm saying. It's like there's this top-down, hey, Bastien, can you please teach this in requirements? And I'm thinking to myself, gladly, what else should I leave out? Because I can't do it all. And there's my bottom-up approach where I'm like, okay, among all these other things that I have to teach, I can't focus. I'm only one man. So I'm only one person.
If you're teaching collaboration and teamwork, by definition, some of those topics fall into that category.
That is absolutely correct. And now please help me explain that to my administrators. That I'm like, great, gotcha, we're already done, way ahead of you. But that's not how this works, right? So we have to now do something and define learning outcomes, or at least show that we're aware that these are learning outcomes we have to now instill in our students. And it's not like I'm unwilling or unhappy about it. I'm just thinking that please do this now. It's like a switch that gets flicked for me and I don't have a choice, right? And that's the conflict that I mean earlier. And this is why we're trying to define here, and this is the same thing with the governing authority of the university, which in our case is the State University of New York, which has like 66 campuses or something like that, and which is also accreditation authorities. And after all of that is said and done, all the paperwork is filed, I still have to produce graduates that find a job. They're still getting hired along with the other graduates from Buffalo and Binghamton and Rochester, and to name a few, and Clarkson, and to name a few good schools in the area here. So it's really tough to manage that, right? And this is just the environment we live in.
You're just frustrated right now.
I'm just saying that
He's
there's
ABETized.
Yeah, you're ABETized. That's a good word.
Right. And by the way, they told us that please get ABET now, and we said why, and they said it would be great for our recruitment of our students, and we said yeah, we know. So can you do it? And we said again why? We have plenty of students. So there's just those are conflicting interests. And I mean, in the end, we all do it, and it's all good. We're doing it for the good reason, and I'm pretty sure it makes our curriculum better. The thing is, though, this is the environment we live in, right? So this is why students have these competencies, and this is why we have knowledge areas, and this is why we're defining things the way we are doing it.
Well, what we're doing with this competency idea is to try to justify some of the things you're complaining about.
Yeah.
Because if you accept, let's say, I'll take the same thing, the medical school model, which is knowledge, skills, and dispositions, okay, then, and you mold it to what you believe it is, you can construct your own, your own environments for software engineering. I don't know how much time we have, but probably not too much, but we might want to also think about, eventually there's going to be a replacement for SE 2014. It might be 2024. What will that look like? There might be a new SWECOM model because that's already from 2014. There might be another SWEBOC model. I don't know, but in the next 5 years, new things will evolve. And I think the software engineering people are great at doing this because I really have Nancy's experience from 3 years ago, that they really come in as a team and they try to get it done. So when these evolutions happen over the next few years, you could kind of mold what it should be. But I'll leave that up to the software engineering pros. Nancy, was there another room that had a report, or did
I think that was it. I think we heard from 3 of them.
Oh, okay.
I think we've wrapped up.
Yes, we should go. I don't know if we have any slides left, but whatever they are, we need to look at them.
Okay.
It's future activities, and I'm not sure, John, if you had slides to support that.
No, I didn't have. Future activities was just an open discussion this was just to get used to this this competency model. Again, for the 3rd time,
Go to the next slide.
Yeah, taken basically from the medical school model. And if you have some interest in it, like if you think it's worthwhile pursuing, then what would you do about it in the future? You do know that there'll be a new SE 20, something, maybe 2024, 2025 curriculum guidelines down the road. I don't know if the Computer Society will be doing anything else with SWEBOC or SWECOM. But so it'd be nice to hear from the audience what they think about where the future might go with this. if at all. Maybe it's a rejection of it. I don't know.
I don't think anyone's going to reject it, and that's for two reasons. On the one hand, administration urges us to follow something standardized. So we are happy if someone presents something standardized where we can say, here, listen, these brilliant people suggested it, and that's why it's not just us thinking this, it's other people saying it too. And I know that my university is, they believe that, because they believe that we are the experts in it, and they believe that we are the experts in recognizing experts in our field. And the other thing is that it's, this is something that is based on something that's proven. That's what I meant to try to convey earlier, right? These, the accreditation, I have like a love-hate relationship with that. But these curricula, right? We've recently made an effort like 2 years ago or 3 years ago to make sure that our software engineering program is SE 2014 compliant. And to our positive surprise, we mostly were. But the trick here was to find those areas where we were deficient. And this is we were just done doing that and making our program really nice when they said, hey, great, and now do accreditation, please. So it's, I guess what I'm hoping for is that these individual, ABET accreditation, CC 2020, SE 2014, I kind of wish it would be, moving together in some way, converging to some degree. And I know that I guess I'm asking too much.
The miracles.
Yeah.
But actually, it actually happens because, for example, the Computer Science 2013 curriculum guidelines that ACM and the IEEE put together, that affected the ABET, so usually they complement each other. I don't know how about other, non-US, but they all look at it, and we borrow and copy from each other, and it's probably okay,
And by the way, you remember my talking about how John recruited me. All of your names are being noted for future activities.
Yes, be prepared to participate.
Oh no.
Gerhard, we're going to appoint you as the chair of the Software Engineering 2026 curriculum recommendations.
Nice try. Nice try.
Nice try.
I figured that. Well, think about those things. That's what counts, as you move forward.
Thank you. Maybe
anything else from anyone else?
Any other comments from the audience? No,
I would like to know how many, what are the countries? Because we have Siberia online, the United States, Canada, and I don't know the other people where they're from.
Germany and Austria, I guess.
Okay.
Excellent.
Okay, excellent.
Yeah. Pierre, would you like to say some closing statement or something, or?
No. Sorry that I had to, family reason, for a certain time off. Sorry for that.
Oh, no, that's okay. No, I meant Pierre.
Perhaps the closing statement would be for, based off of Bastian. Yes, it's very easy to want to add things in curricula, but when you add things, you have to remove things, and that's where it gets very difficult. So a set of competencies which are, I would say, attainable and balanced would be very useful, but they have to be achievable in the context of real curricula that has to operate in the real environment with real budgets and real ABET guidelines and so forth. So that's where it gets difficult. It's very easy to do this type of exercise and put evaluating everywheres, and when you actually get to implement that in the curriculum amongst a whole series of constraints, that's where the rubber hits the road and it gets more difficult. So this has to be well thought out. I
guess you're right. It works though, right? It's, a couple of, not too long ago, like 10 short years ago, every computer science program had we just talked about this in one of the networking sessions earlier. And 10 short years ago, every computer science program had some assembler or some kind of system Z course, right? And these days, assembler is maybe something you learn in the realm with microcontrollers or things like that. So it's not really relevant anymore. But then again, these days, we're trying to incorporate requirements as early as possible, right? So I guess the profiles, the qualification profile of the graduates shift, so does the curriculum. So,
and it should, this type of set of competencies, to follow up upon Bastian, should also help us to explain to university administrators, to future students, to the population in general, what the heck is different between these numerous IT computing programs that are available: software engineering, computer science, software, computer engineering, and so forth. It's very, very difficult, getting more and more difficult to explain. This type of document could be very useful in such a discussion, because they're getting hard to explain. Even Nancy talked about that at the beginning, and it's not getting easier. Otherwise, I'd like to thank everybody and for sticking right to the end, and especially maybe our colleagues on the other side of the pond, over the other side of the pond, and especially way, way on the other side of the pond, nearly on the Pacific Ocean, and halfway there in Siberia. And I know it's very, very late for you, and I will thank you all. And maybe the four of us can stay online for a couple of minutes and discuss amongst ourselves, debrief a little bit.
For a few.
Thank you much, guys. I can tell you, before long, I'm sure we'll be asked to look at CC 2020. So this was really helpful. Thank you very much.
Thank you.
Thank you.
Thank you very much. Bye.
See you soon.
Bye.
Bye-bye.
Okay, it's just us.
First of all, thanks to Maddie for directing this, technical coordinator. That was a good term. And
yes, Marie, that was wonderful. I wanted to call
that. Thank you. I'm very pleased. Yeah, but it's the work of the four of us, but everything went fine.
Yeah, everything was. Yeah. I thought it was a good session, and I'm glad we got some controversy and pushbacks on things, and it makes one think about,
and I think we learned about holding such a session virtually, and we'll be, no matter what happens after, we'll be doing more and more of these sessions. I mean,
at least for 2 years. Yeah,
it was interesting. I don't know, and we'll find out if people will look at it later because they were in some different time zone, because the numbers were very small compared to what we might have expected. I'll touch base with Rick Kasman at some point to find out what happened this session, which would have been 4 o'clock in the morning for us.
I suggest that we're being recorded here, so they're going to have to edit this.